Here we go. Graph the polar coordinate. Hopefully, your polar coordinate looks like this. If you were to make yourself a makeshift circle and go out 2 units, 11 pi over 6 is, well, let me put some axes on here. 11 pi over 6 is here-ish, but the negative angle flips you over the x-axis and the negative radius flips you to here. So here should have been roundabout where your polar coordinate lieth. Questions? Good. We're skipping a few sections today because the polar coordinate stuff goes straight into what we're learning about today, and that is vectors. You may turn it in now, or you may turn it in later with your homework. I would just turn it in now. Turn it in. 6.6. Sure I did. 6.6. See, I'm all over it today. Seis. 6.6. 6.6. What? Why? Am I really? Yes, I love cussing people out accidentally. Yes. 6.6. Bah! I want to learn how to cuss in German. That's the angriest language, in my opinion. Like, Schwager, Schwager! Ooh, how do you say it? Shut thy moon? I can't say anything mean with the word moon in it. Okay. Alright, here we go. A vector. The reason today blends perfectly with yesterday is because a vector is the exact same thing as a polar coordinate. In that, actually, let me go back to the DOM for a second. A vector is just something that has both magnitude and direction. So, for instance, this vector here has a length of 2, and it goes in the direction of 11 pi over 6. Vectors. Magnitude and direction. Now, vectors look like rays when you draw them. Like these two. You might look at that and say, oh, those are 2 rays. But the arrow does not imply that it keeps going. That is not the point of the arrow on a vector. The arrow on a vector implies which direction it was going. So, like, without that arrow, you wouldn't know whether it started here and went this way or started here and went that way. Vectors are used very, very often in travel. You know, an airplane traveled along such a path, etc. So, the arrow at the end. Notice the tip stops perfectly at the terminal point where it ends. So today, I don't want to see anybody drawing vectors like this. If I asked you to draw this vector, I don't want you to be like, yeah, there it is. No, it doesn't. You're just way too long. It needs to stop at the point. It needs to stop. It's a precise arrow. V-E-C-T-O-R. Have you ever seen Despicable Me? Yes. He even says he has both direction and magnitude. Now I get it. Yeah. Yeah. We should watch that now, right? No. Okay. So, U and V have the same direction. It tells you in the instructions they have the same direction. In each exercise, see how it says like double absolute value? The word for that is magnitude. Magnitude. The magnitude of a vector is just how long it is. Now, if this was just a segment, and I asked you how long it was, how would you do that? Well, no. Well, actually, yes. Yes, we could do that. What did we do yesterday? You could do distance formula, or you could just do Pythagorean theorem. Either one would work. Now, here's why distance formula might be the smartest way to go. You can't just take the final coordinate because they won't always start at the origin like this one does. So, I mean, you could draw it and count your spaces and plug it into the Pythagorean theorem. But the safest way to do it is to use the distance formula. The magnitude of a vector is the distance. So, to find the magnitude of u, we're going to do the distance of the initial point and the terminal point. That's the starting point and the ending point. Initial, terminal. So, if you don't remember the distance formula, x1 plus x2 minus x2. x1 minus x2 squared plus y1 minus y2 squared, negative 5 squared, negative 4 squared. And what is that, radical 41? You're just letting me do all the work. Yes, ma'am. Now let's try vector v. In order for these magnitudes to be equal, in order for these vectors to be equal, they have to have the same direction and the same magnitude. They don't have to be right on top of each other. It's like if I were to say, we're going to, if you started driving from here and your friend started driving from here, have you made the exact same trek in your car? Even if you go to different places, if you drive the same direction in the exact same distance, then you've made the same drive. So, that's what these are saying. You could have 1,000 little vectors all right next to each other, all be congruent, and none of them actually touching. As long as they're all going the same direction and have the same length. Well, they told us they were the same direction, so they did the hard part for us. And I'll be teaching you how to do that later. All we have to do is see if they have the same magnitudes. So, distance formula for the second one. Let's see, 5 minus 0 squared plus 4 minus 0 squared. 25 plus 16. Not rhetorical. 41. Are they the same? Yes. And if those had been different, then it would be no. Distance formula, x2 minus x1 squared plus y2 minus y1 squared. All under the radical. And again, what is this called? Magnitude. Very good. The magnitude of a vector. Questions about that slide? No new math so far, just new concepts. Do I need to leave this on the board? Please. Hop off. So I'm petitioning for them to just cancel the weekend so we can just start up again tomorrow on Monday. What do y'all think? Just kidding. Let me tell you something. Teachers look forward to it almost as much as you kids. I say almost. Probably more. Probably more. Hey, we're molding your futures. When I say we, I mean you all. You all are molding your futures. You just don't see it quite that way yet. So let me get this straight. You want to get paid not to be a fungus to society. Oh. I am not a societal fungus. Where's my money? Congratulations. You're not the scum of the earth. Okay. Moving on. So, are these vectors equal? Look at them. Tell me. Well, calm down. Katie Beth, how am I going to determine whether these vectors are equal? I will. Of course, when they're perfectly straight up and down or left and right, what's another thing you can do? Yeah, just see if you can count it if it's pre-graph for you. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yay! And are they going the same direction? Let me ask you this. What if everything was the same except this? And that's just a point down here. Now, they are not the same. Because even though they're parallel, one of them is going right, the other would be going left, and they would not be the same. Direction matters. One of those is heading due east, the other one's heading due west. Couldn't be more different. So, but as it was, yes, these two are the same. Questions? Click. Sketch each vector. Okay, don't ask me why they chose I and J. I don't know. But I do know that I and j is just a little formula way to write the components of a vector. And these are quite simple. Watch this. Vector v on number 5 is 3 units to the right. Now, it would be awesome if this was on a coordinate plane and it would just be 1 unit. And 1 unit up. So vector v on number 5 is this resultant vector. This is vector v as represented in terms of 3i plus j. I are the horizontal components, j is the vertical component. Why do you think I went right and up? One of these. One of these. Come on, raise your hand. You know you want to answer it. Yes, Lazarus. Those are both positive. Very good. The raise your hand thing was the deal breaker. Okay. Number 9. Who can tell me what direction number 9 is going to travel in? Yes, Sam. Very good. Left and down. X, Y. Left, down. Very good. Now it says sketch them. It's left because it's negative. This was number 9. This wasn't number 7. It was number 9. It was left and down. So it'd be left 6. Now you may be saying, why is he just drawing this out in space? Because vectors are just out in space. They don't have to be exactly on a coordinate plane. Of course, I guess, how do you measure a unit out in space? But that's not the argument for right now. So there would be your resultant vector. So today, it just says sketch each vector. Oh, and find the magnitude. I forgot to do that. But I would prefer if you drew it with little arrows so I understood. So you show me that you understand what those numbers do. Now, the magnitude of something that gives it to you in component form like this is ultra easy. Who thinks they can tell me a quick way to find the magnitude given what we're given? Pythagorean theorem. Your coefficients are the numbers. 3 squared plus 1 squared equals well, I'll call it m squared. For number 5, that's your magnitude. What? 9 plus 1 is 10? Wow, 4th time's the charm. Radical 10. Or you can give it to me as a decimal. Who can tell me the formula for finding the magnitude on number 9? One of these. Number 9. How am I going to get my magnitude? Justin. Very good. Why is it not necessary for him to use the negatives? That's right. When you square it, the negative becomes irrelevant. That's why I always do it. Now, if you want to be proper, then by all means, go ahead and throw your negatives in there. The problem is, if you forget to use parentheses on your calculator, it's going to give you the wrong answer. So to avoid that conundrum, I just never put the negatives on in a Pythagorean theorem. So 40 equals m squared. So what's m? Ooh, you actually gave it to me in reduced form. Muy bien. That's very bien, in case you all don't speak Spanish. Sure. Number 11. Now, good question. We're going to work it via Pythagorean theorem, but I think you'll very quickly see how you can kind of skip if it only has one component. So, judging by this, what do you think is just a quick thing you can do anytime there's only one component? Well, for the magnitude. What do you think you would do for the magnitude? Yeah, just exactly. Just take the absolute value of whatever coefficient it is. Did you want to see the graph? Or just, yeah, to the left. Well, that's not really bad. Yeah, to the left. Except you'd have to do it 4 times. To the left, to the left. Although that'd be a funny way to do vectors with that song. Except I would give you like minus 37. You have to say it like 37 times. And then I do 16 plus 16, like. I'm not going to do it. Questions about this slide? Oh, let's see. No more questions about this slide? In exercises 13 through 20, let V be the vector from initial point P to terminal point P2. Initial being where it starts, terminal being where it terminates. Write V in terms of I and j. So, easiest way to find these. Your I value, the number that goes with your I is just the difference of your x's. You always want to go terminal minus initial. So, 6 minus negative 4 is going to give you your i's, and 2 minus negative 4 is going to give you your j's. So, what's 6 minus negative 4? And what's 2 minus negative 4? And there you go. Terminal minus initial. 10i plus 6j would be the vector. And even though I don't ever see it denoted like this, you know how like segments have a bar and lines have 2 arrows on the end? I always love vectors. They have like a feather in their cap. It's not a ray with a full arrow. It's like a little... But yeah, right? That's why I always saw them. Vectors were like Robin Hood. Anyway, try to find the component form of, I hate calling it component form, because when I was in school, this was technically the component form of a vector. Mr. Cox, which one did you learn, the i's and j's or this right here? Yeah, see, I always heard, that is the symbol for a vector. You know how like segments had just like a dash and lines had 2 arrows and the right had 1 arrow, and you did it in geometry. You're looking at me with like no expression, so I don't know. Well, this is vector. Okay, try to, yes. Oh, for the i's, it's always the x's, and for the y's, it's always the j's. Try to find the I and j form, since I refuse to call it component form, because it's not. Try to find the I and j form for number 17. 17. Although 19 looks fun. Say 10, 17? What? 17? Who here took German with Mr. Hoff? Does he ever just go off on y'all in German? No? Man, if I taught German, I would cuss in my class all the time in German.
You say about how happy you are when you say like
Wouldn't it be funny if like all the students do it, but like the observer didn't? So like let's say like an administrator's in there and you're like, well, this is bleepity bleep guy over here, but he had no idea what you're talking about. That'd be awesome. How do you say it? Coo is cow? They took cow and moo and meshed it to coo? Really?
But McCall and I, we wrote like this note, and it was like inappropriate things on notes. It was funny because it was on German. I mean, it wasn't necessarily in proper form or anything. We didn't take it up, so I found it in my diary. And I stuffed it away.
You lied. That's
I
funny.
had to. It thought we were crazy.
That's really funny. I wish I taught something where you could do that. Okay, who got my IJ form for number 17? Yes. Well, I don't know. You didn't give me any. -6 what?
oh, sorry.
Very good. Did anybody get something different they'd like for us to take a look at? What about 19? 19. What would your J value be on 19? 0. You don't have to write, what would that be? Let's see, 9i plus 0j. You don't have to write 0j. It would just be 9i. So if you have a 0 component, just don't even bother. Questions on that slide? You know, if I had rolled my ankle, it wouldn't be so funny. What if I was writhing in pain? What? No, I tripped on the book. No. I would be a little more upset. Okay. Vector math. These are just as easy as they look. Without me telling you a simple thing, Sam, what do you think is the key to adding and subtracting vectors? That could be the correct answer for any math K through. Who wants to be a tad more specific? What do you think is the only key to adding and subtracting vectors? Ryan. Like terms. That's right. U plus V. U plus V. 2i plus negative 3i is negative I. Negative 5j plus 7j is flu j. It's really U. 2j. But anyway. Vector U plus V is negative I plus 2j. Preguntas? What are they? Didn't you just say yes in French? Well, then I think you meant to answer me in Spanish. No. I don't know why I erased that. Alright. Let's see. Let's just do thinking of this on our own day. Jordan, how do you think I'm going to do number 31? Just, if you had to guess, if this was the ACT and you've never seen it before, how would you try to work number 31? So what would W equal when multiplied by 3? Well, just minus 18j. That's right. That's very good. And that's all you have to do. These, just don't overthink them. That's why people sometimes miss these. They think they're harder than they are. That's 3W. 2V. This is 31, by the way. 2V would be negative 6I plus 14j. And then you add them together. So negative 3I minus 6I. Negative 18j plus 14j. And very good. And every single problem on the board, by the way, this is called, whenever you multiply a number by a vector, it's called a scalar. Because you haven't changed the vector's direction, but you made it longer. You scaled it. What I mean by that is, like V goes 3 left and 7 up, so about like this. Thank you. But 2V would be like this. Direction wouldn't change. Well, it shouldn't change. I didn't draw it right. But you just doubled its length. So a number being multiplied by a vector is called a scalar. So that's definitely a piece of vocab you want to remember, because on a test it may mention it, and all it means is the number you're multiplying by. Is there a problem on the board somebody would like to see worked? 37. Well, actually, I can't take this elsewhere. I need the vectors. 37. W minus U. And then you're going to take the magnitude. So W, negative I minus 6j, minus U, which is 2I minus 5j. So negative I minus 2I, negative 3I, negative 6j, minus a negative 5j, negative 1j, j. And then you need to find the magnitude. So 3 squared plus 1 squared equals m squared. That's square root of 10. So you do the order of operations. You do it inside first, and then magnitude it up. Questions? You're going to have, I don't know why I'm telling you this now, but I may have already told you this. That your test will be next Wednesday or Thursday? Yeah. Okay. Yes, ma'am. Well, the only problem with that is it's the day after the ACT, and I don't know that we'll be in here on the Tuesday, and I'd like to review right before, so we'll see how it goes. There we go. Questions? Okay. Now, this is really what you kind of want to write down, although you're going to pick up on it so soon you probably won't even need it, but that is a little formula for finding a unit vector that goes in the same direction as our papa vector. Let's call it a papa vector. Now, I and j are a horizontal and a vertical unit vector. Yay! One I is a horizontal unit vector, one j is a vertical unit vector, but we are looking at something that's not just straight right, straight left, straight up, straight down. So you can use that little formula. And here's all you have to do. Watch. 3i minus 4j. Didn't it just say v over magnitude of v? There's v. You don't change it. What's the magnitude of number 41? Somebody Pythagorean theorem it up and let me know. 5. That's right. You just take your vector, divide it by the magnitude, and that is your unit vector. It would be 3/5 I minus 4/5 j. That is a vector that is exactly 1 unit long. Let's see, right down. That goes in your direction. Okay. Let's look at 43. 3i minus 2j. Somebody calculate my magnitude for me, and then raise your hand, and then raise your hand. Sure. Thank you. I have a tendency to skip steps, don't I? Magnitude. You take the two parts, put them in the Pythagorean theorem. 9, 4. Ryan, did you get square root of 13? Yes? Okay. Radical 13. However, oh no! We have to do what to this? We have to rationalize it. So, it would be 3 over radical 13i minus 2 over radical 13j. Who remembers how to rationalize? Marco. Exactly. Multiply both the top and the bottom by radical 13 over radical 13. So that would become 3 radical 13 over 13i minus 2 radical 13 over 13j. It's just the vector over the magnitude, and you may have to rationalize. Oh, that's nice. You think you're bored? Mr. Cox has to sit and do this like every day. Yeah. Because he's a very polite person. He doesn't vocalize when he's bored. Okay. Verbalize? Vocalize. Questions? Any questions about what's on the board? Like that one? Sure. We're not done. When you say any problem of that variety, before I would make one up, but this one, who can tell me what number 39 would be? It's the vector. What's the magnitude? Yeah, the magnitude of a one-directional vector is just that, so it would just be I. So that one's kind of simple, so we won't do that one. How about this made-up example? What if we made up the problem negative 4i minus 2 radical 3j? Oh, no, we didn't. I can't imagine you could. You know what? No. It's one thing to make up a hard example, but you're not going to have to do that. So, fine. 69j. Okay, we're moving on. We're not even going to talk about that. Pythagorean theorem. Now, Sam, you asked for it. I need my magnitude. You can just tell me square root of that number. No, it's not. You gave me like the perfect number. What was the pre-rooted number? 3,774? Oh, okay. Whatever. Okay, now you cannot round it to 69.1. You have to rationalize it. So, because of our lovely number choice, that would be 4. It would be 4 radical 4,777i over 4,777 minus 69 radical 4,777j over 4,777. What did I do? Oh. Sam must have been so incomplete. Anyway. Questions? Giggity. Alright. Touche. Yes, it would. I got a little caught up in my... Never mind. Questions? Bridget, is that what you need to say? Alright, last slide. Now, we're going to take vectors, and let's see, we are going to find their I and j. However, I think you're going to agree this is exactly like something we may have just done 30-ish minutes ago on the board during the homework questions, because here's what I'm giving you. I am providing you the radius and theta, the r and the theta, and just like yesterday, I need to find the horizontal and vertical component, which are very, very similar to an x and y coordinate. What did we do for that yesterday? We did r cosine theta and r sine theta. Well, that's essentially the exact same thing we're doing today. To find the I and j's, here's your formula for today. I equals, it's really r, but I'm going to use m for magnitude since they're giving you the mag. Magnitude cosine theta, and j equals magnitude sine theta. And from here, you just plug them straight in. So, like 49, that would be 12 cosine 225. What do I need to be in my calculator? Degree mode. And 12 sine 225. That'll give you your I and your J. Kevin, will you punch those in and tell me what you get, please? Yes, ma'am. Because it was, I don't know. Yes. $6.5. Oh, I'm sorry. Okay. And then 6.5. Oh, really? Why do you think you got the same thing for both? Logic time. That's right. This is 225, which has a reference angle. Y'all remember that piece of vocab? Of 45, which means if you were to kind of draw a little triangle on your unit circle, or on a circle, it would be an isosceles triangle. Anyway, that's just a little piece of tidbit. Or you can just write down the numbers. You don't have to think about that. Yeah. What?
Is that the one that it is produced?
Oh, did you actually? Oh, very nice. Because you had your unit circle. And you said cosine of 225 is 2 radical 2? Or negative 2 radical 2?
I just learned the decimal that day.
Oh, well, there you go. Or, I guess if it's on your unit circle, you could just take cosine of 225 taking unit circle. Yeah, that'd be good. But of course, on this one, you wouldn't be able to. Questions about how to work those? The magnitude is your R from yesterday, and the theta is your theta. Yeah. All right.
Oh, they go to